Ready? Okay, so today I thought I'd look at a particular problem that you might come across in relation to vector equation of a straight line. So I have the problem on the board. The equation of the line is this, and we have to find the coordinates of a point P on the line such that OP, the line from O to P, is perpendicular to the line. Okay? So let's have a diagram to demonstrate this. Although it's in 3 dimensions, a 2-dimensional diagram will do. So this is the equation R equals 1, 0, 2 plus T 1, negative 1, 0. Which means, of course, don't forget that this is the coordinates of a point on the line, or at least it's the position vector or point on the line, which basically is the same thing. And this is a vector in the direction of the line. So we have a vector there. 1, negative 1, 0. Okay? Right, obviously we need an origin. And what the question's asking me is where is the point P on the line such that that is a right angle. Happy with that? Okay. That's where we've got to go. Right. Now, as soon as you see perpendicular at right angles, whatever in a vectors question, it's virtually guaranteed that you're going to use the fact that the dot product equals 0. Or should I really say the scalar product equals 0, okay? But of course what that means is I need 2 vectors to do the dot product of. So in other words, I need a vector in that direction, and I need a vector in that direction. Well, obviously we've got that one. What about this one? Right, this is where lots of students start scratching their heads and think, I don't know. Right, but remember how the vector equation of the line works. This is a real scalar variable. Any real number that you care to put in there will generate a vector from the origin to somewhere on the line. Okay? So in particular, there must be a value of t that will generate the vector from the origin to P. So let's say that the value of t that gives that vector is t1. That means that this vector is 1, 0, 2 plus t1, 1, negative 1, 0. Now what that means is, therefore, is that I now have 2 perpendicular vectors. And because they're perpendicular, I know that if I work out the scalar product, it will be 0. So, I can now get rid of the question. Well, I'm going to have to get rid of the question because I need the space. So, I need to dot that with that. So I have awkward silence with that. And I know that that is going to be 0. Okay? So, remember, the dot product, if you've got it in component form, the dot product is basically multiply the x coordinates, multiply the y coordinates, sorry, I should say components, not coordinates, components, multiply the z components and add them up. Well, the x component here is 1 plus t1 times 1. Okay? That's rubbish. This is where Mrs. Cross can now do an outtakes video. And you've now got a flavour of what being in my lesson can really be like. But times by that one, so I've done the x component times the x component. Plus, of course, the y component, which is minus t1, so I don't need brackets, so I don't need the plus either. That's the good thing about doing whiteboards, they're easy to rub out on my pen. Minus t1 times that. Plus, of course, the z component, which is actually 2 plus, well, nothing. So it's just 2, and again, times 0. And I know that altogether that has to be 0. Well, I've simply got an equation in t1 that I need to solve. So if I expand the brackets, I've got 1 plus t1 minus t1, no, plus t1 equals negative times negative. That 0 equals 0. Which I think therefore gives me 2t1, take that over the other side, gives me negative 1, and therefore t1 is negative 1/2. Now remember though that T1 is the value I can put into the vector equation to give this vector. So that's all I need to do now, is put the -1/2 in there. So I will have 1, 0, 2 plus -1/2 times 1, -1, 0. Right, so I've got 1, take away 1/2, so I think that's 1/2. That's nothing plus 1/2. And obviously that's nothing, so it's just 2. And that is the position vector of P. I believe the question asked the coordinates, or maybe it was position vector, but if it was coordinates, you should rewrite this as 1/2, 1/2. So would I very much doubt that you would actually be penalised if you left it in that form, as long as it was clearly your answer. So it looks a bit odd because it looks like you're just dotting the equation in a straight line with a part of it. But that more or less is what you're doing. It looks a bit odd, but it is correct. Okay, hope that's been helpful. This is Mr. Mitchell for CCHS News, signing off.